Hello everyone, welcome to the channel. This is the first video of BERT series, and in this tutorial we are going to take a look at BERT architecture. Then we'll fine-tune base model from the hub and adapt it to medical domain on a toy dataset. BERT stands for Bidirectional Encoder Representation from Transformers. It uses only the encoder block from transformer architecture, with self-attention on both left and right direction. It's useful in the way that sometimes future tokens have clues for what current token is referring to, which helps in richer understanding of context. As you can see in the example, meaning of the word date not only depends on previous tokens, but also on future tokens. By attending tokens on both direction, model learns to better represent a token in a sequence. It has architecture similar to transformer encoder, with few modifications. For example, it has additional token type embedding for each sentence. The pre-training goal was to learn contextual representation of sentences. It was trained on two tasks, simultaneously. First, to predict masked token, for contextual understanding. Second was to predict whether sentence B naturally follows sentence or not, which helped in understanding relationship between two sentences. When masking tokens, only 80% of time it was replaced with mask token. This helped in rich understanding of syntax, grammar and semantics. %10 of the time it was a random word, so that model adapts to different domains, and account for rare tokens in fine-tuning stage. And 10% of the time, token were kept unchanged to incorporate factual information and general knowledge in the model. The pre-trained BERT model can later be fine-tuned for many NLP tasks, by simply training additional head on top of the model. This notebook can be used for domain adaptation through continued pre-training, masked language modeling, and next sentence prediction task. You can train a BERT model from scratch if you initialize BERT model from config. The pre-training model has embeddings, encoder pooler and pre-training head. Let's collect a tiny corpus to train the model. I'll combine question with response to create a document. Then split documents by new line to get different sections. Split each section with dot to get lines. Then I'll create pre-training style dataset using these document lines. For actual sentence sequence, I'll use consecutive lines. For random sentence sequence, I'll use random line from random document. Let's inspect the tokenizer. When you input a sentence pair, notice how it adds special CLS and SEP tokens to differentiate sentences. Let's tokenize a batch. Take a look at token type IDs and attention mask. Attention mask is all one, since there are no padding tokens. Now let's add more items in the batch of different sequence length. Token type IDs now has zeros in the start, 1 in the middle, and 0 again, which is incorrect. The attention mask helps in ignoring padding tokens at the end. See, the last attention mask is all ones, because it is the longest sequence. Let's look at our data collator function. This whole word mask collator inherits from language modeling collator. Look at the default probabilities. Isn't it similar to BERT pre-training? We get a batch and create batched inputs to the model. These inputs are required by forward method of BERT for pre-training to calculate loss. Passing batch of sentence sequences to the tokenizer, it returns input IDs, attention mask, token type IDs. Then we pass input IDs to whole word mask collator to mask and replace some tokens using default probabilities. It also returns the correct labels for tokens that were masked. Let's have a look at the predictions made by current base model. Loss is calculated only for masked tokens and next sentence label. Time to test our model. Let's pick a sentence. It gave Loeb second rank. Now let's see what base model thinks. Nothing medical related. So this is how you can adapt a BERT model to your domain-specific dataset. If you liked this video, don't forget to subscribe to my channel. Thanks for watching. See you in next one.